Hello, everybody, and welcome to this week's lesson. This week we are on to Unit 10, Writing and Solving Linear Equations. So this week's unit definitely builds on our last 3 weeks of working with functions and using our algebra vocabulary. So if you have not worked on Units 7, 8, and 9, I definitely urge you to go back and work through those lessons first before you try this one. Materials you're going to need today: pencil and paper, your welcome packet, a calculator might be useful, and then also our lesson notes from the last 3 weeks / any homework notes you have might be useful too. All right, we're going to get started with this warm-up question here. I would urge you to pause the video and give the warm-up question a try, and then come back to the video when you're ready to talk through it with me. All right, so this question says, the equations below show the total earnings for 2 employees based on commission. The variable X represents the amount of money the employee has made in sales. The variable Y shows the employee's earnings. If each employee makes $500 worth of sales, who will earn more money? So this is actually a problem taken straight from our lesson last week. So if you watch that lesson, this should look really familiar to you. This is one of the practice problems at the end of the lesson. So let's think about this here. If you've ever worked on commission, and this situation might sound familiar to you, but when you work on commission, usually you earn some percent of your sales. So if we look at these 2 equations, I see that this is saying employee A's earnings are equal to 0.2 times the amount of sales, the amount of money they make in sales. And then for employee B, their earnings are equal to 0.3 times the amount they make in sales. So you could actually answer this question without even paying attention to that $500 worth of sales. If someone makes 0.2 times whatever amount, that's going to be less than someone who makes 0.3 times whatever amount. This is really, for employee A, this is equivalent to saying they make 20% of the sales. Right, 0.2 means the same thing as 20% if you think back to our percents lesson. And for employee B, it's saying they make 30% of whatever sales they make. So if employee A makes a 20% commission and employee B makes a 30% commission, employee B is making more. So you can kind of figure that out without even substituting that $500 in there. But let's go ahead and let's substitute $500 in there. So we want to know, how much will employee A make if they're earning 20% of $500? So 20% of $500, you can go ahead and pull out your calculator if you'd like to. That would be 0.2 times 500, which is $100. So they will make, employee A will make $100 if they do $500 worth of sales. What about employee B? So they are doing 30% of 500. 0.3 times 500 is 150. So employee B is going to make $150. So who will earn more money? Employee B will earn more money. All right, so our learning goals for this week. By the end of the week, you will be able to write linear equations in one variable to represent context, solve linear equations in one variable, and solve real-world problems involving equations. So that means like word problems. All right, so linear equations. We have already talked quite a bit about linear equations. We have been focusing on 2 variable linear equations when we've been talking about functions. So we've seen linear equations that look like this, where we have our output y is equal to the slope times the input x plus or minus the y-intercept. And then we talked a little bit about proportional relationships, which have a y-intercept of 0. And so their equations look like y equals the slope times x. So either way, we've been looking at these input-output relationships where y is equal to some number times x, maybe plus another number. So two variable linear equations, they show the relationship between an independent variable x and a dependent variable y with a constant rate of change. So that's the slope, which we call m or k if we need to. So two variable linear equations are all about just showing that relationship. They're not about they're not there to specifically talk about like one specific input value or one specific output value. They can be used to do that, but they're really there to describe the relationship. What we're going to see later on when we talk about one variable linear equations is that the purpose of those is to help you figure out one specific input value. So we'll see that in a minute. We want to remember when we're using the word equation, equation is just a mathematical statement that two expressions are equal. So we're saying this is the same as this. This is equal to this. It's this mathematical statement that two expressions are equal. We want to remember that an expression is just some sequence of numbers, variables, and operations, right? So 2 plus 2, that's an expression. Or 5x, right? 5 times x, that's an expression. Or x squared minus 37, that's an expression. Okay, so let's look at an example for a two variable linear equation, and then we're going to compare it with a one variable linear equation. So Marta is a salesperson who works on commission. Each week she earns a base salary of 200 plus 25% of the sales she makes. Write an equation that represents Marta's weekly pay. Let y represent her weekly pay, and x represent the dollar amount of sales that she makes. So she earns her weekly pay. Let's think about what are the components that go into her weekly pay. Well, she's got that base salary that she makes. And then on top of that, right, it says plus, she makes 25% of the sales that she makes. So that's the commission. So plus the commission that she is earning. So I'm going to fill in these words that I'm going to do a second take of this equation where I replace the words with the actual algebra. So her weekly pay, that's y, equals her base salary, which is 200, plus 25% of the sales that she makes. So typically what we would do, take that 25%, write it as a decimal, 0.25. When we're talking about a percent of something, that's multiplication. So 25% of the sales, that would be 0.25 times x. And there's our equation. We could also have written it this way. So y equals 200. No, that's not what I meant to do. I meant to do it the other way. Y equals 0.25x plus 200. Same thing either way. The thing I want you to focus on here, though, is the point of this equation is to describe the relationship between how much she makes in sales and then the resulting earnings that she gets as her paycheck. So we could plug in any amount of sales that we want to here, and it would help us figure out how much she is actually going to make. Okay, so now let's take the same situation, but look at it in terms of a one variable linear equation. So Marta is a salesperson who works on commission. Each week she earns a base salary of 200 plus 25% of the sales she makes. This week, Marta earned 800. Write an equation that represents Marta's weekly pay based on her sales. Well, let's first think about that original equation we made. So we said y equals, let's just say 0.25x plus 200, right? This is describing that relationship between sales and earnings. But now we have an extra piece of information here. We know that we are talking about a specific output. Marta earned $800. So that means we can replace Y with 800. So last week when we talked about evaluating functions, what we practiced doing was taking a function and then evaluating it for a specific input. Basically what we're going to be doing today is we're going to be taking a function and evaluating it for trying to figure out what the input is given an output, right? So here they told us what the output is, and we could try and figure out what the input is that goes along with it. That's what we're going to be learning today. We're going to be learning a process that helps us to figure out that missing input, that missing X value. So this equation right here, this equation represents Marta's weekly pay based on her sales X, right? So her weekly pay was 800. So 800 is going to be equal to 25% of whatever sales she made. We haven't figured it out yet, plus 200. Okay, so writing one variable linear equations, which is what we just did in this example here. It is really a matter of becoming comfortable with the language in the problem. So you're going to be wanting to really focus on keywords and phrases. And I would highly recommend that you have your welcome packet out next to you, because in your welcome packet there is a handout that's about halfway through. And I believe at the top it says something like keywords and phrases. And then it shows you like common words that show up in word problems and what they're telling you to do. So I would take a minute to go and find that handout in your welcome packet. And then once you found it, you can come back to the video. So let's get some more practice with writing one variable linear equations. We've got a whole bunch of examples on here. And what we are practicing is we're practicing taking the English and translating it into the algebra. So number one, the quotient of a number and 3 is 7. Okay. So first, the word quotient. What does quotient refer to? Quotient refers to division. So it's saying when you divide a number and 3, it's 7. This word is here. This is usually indicating your equal sign. So we know that all of this stuff, the quotient of a number and 3, all of this stuff should be equal to 7. So all of that stuff is going to be equal to 7. So quotient of a number and 3. What number is it that we're talking about? Well, we don't know, right? It's just some number. So that's going to be our variable. That's our unknown value. So the quotient of a number and 3, you could write it like this. You could say like n divided by 3. All right, so this is the quotient of a number and 3 is 7. You could write it that way. A more common way that you would see that division written is n over 3 equals 7. So those are two different ways of writing out division. I would say that fractional notation where you have the fraction bar is much more common once you start getting into algebra. All right, number 2, 2 times a number plus 7 is 19. So I see is right there. So I know that whatever happens first, all of it is going to be equal to 19. All right, we have 2 times a number plus 7. So that's going to be 2 times a number, right? 2n means 2 times n, and then plus 7. So 2n plus 7 equals 19. Now I'm using n here just because I keep saying a number, but you can use whatever letter you want. You could use x, you could use z, you could use j, whatever your favorite letter is, you could use that. All right, number 3, a square has 4 equal sides. Its perimeter is 20 feet. So let's think about this. I'm going to draw a square. Right, a square is a 4-sided shape that has 4 equal sides. And its perimeter is 20 feet. Do you remember what perimeter means? So the perimeter of a shape is the total distance around the edge. So it's basically all of the sides added up together. So this says a square has 4 equal sides. Do we know what the side length is? We're not told what the side length is, right? That's a missing piece of information. So whatever the side length is, I'm going to call it S for side length. So the side plus this other side plus this other side plus this other side is equal, right, is 20 feet. So I could write that in a couple of different ways. I could say S, the side, plus the side, plus the side, plus the side is equal to 20. Or I could think to myself, well, adding something 4 times, that just means 4 times that thing, right? So another way I could say this is I could say 4 times S, or 4 times N, or 4 times X, whatever letter you want, is 20. Now it might jump out at you that the side length of this particular square, it must be 5, right? There's no other number that would work there. So this particular square does have a side length of 5, but if we didn't know that, this equation is still describing the information that we're given. All right, number 4. Tracia made N t-shirts last week. This week, she made 3 times the amount she made last week. Altogether, she made 8 shirts. So last week, she made some shirts. This week, she made some more shirts. Altogether, she made 8. So I'm going to start thinking about how to set this up. It looks like we're given a total amount. So I'm going to think about what goes into that total. What are the components or the parts of that total? Well, it's really going to be last week's amount plus this week's amount. So now I'm gonna, once I have this sort of skeleton of an equation, I'm gonna go in and I'm gonna start filling in, I'm gonna replace the words with actual algebra. So last week, how many shirts did she make? She made N shirts, right? So I'm gonna replace last week with N. And then this week, she made 3 times the amount she made last week. So if last week is N, this week is gonna be 3 times N, or 3N. And then all together, the total was 8. So if you have an N of something, and then you have 3 more of those N's, altogether, how many N's do you have? Well, you have 4 N's, right? So another way you could write this equation, you could simplify it a little bit. You could write it as 4 times whatever N is going to give us 8. All right, number 5. Bill rented a power washer for some number of hours. He paid a $25 rental fee and 50 cents per hour. His total bill was $27.50. So again, this is a situation where we've got this total amount, and we want to think about what are the components that go into that total amount. So let's see. His total bill was $27.50. So I'm going to put that total over here on one side. he's got to pay that $25 rental fee no matter what, right? The $25 rental fee is not dependent on how many hours he has it for. He just has to pay the $25 rental fee. That's kind of the starting amount or the initial fee. And then it's 50 cents per hour. We know that he rented it for some number of hours, right? We don't know exactly how many yet. So if we are trying to show how all of it gets added up together to equal his total, well, it's going to be $25 plus 50 cents times whatever number of hours he rented it for, right? So it would be 50 cents or 0.5 times the number of hours he's rented it for. I'm going to do H for hours this time. So this equation represents his total bill in terms of the number of hours he has rented the power washer for. Now again, I want you to notice here that for each of these examples, we are not trying to figure out what the missing value is yet. All we're doing is we're trying to write out an equation. What we're going to be doing next is seeing how we solve those equations. All right, number 6, the difference of a number squared and 4 is 21. So is 21, I know that means it equals 21. It says the difference, so difference means subtraction. We want to subtract a number squared, so a number squared and 4. So the difference of a number squared and 4 is 21. All right, so let's get some practice here with a couple of word problems. I highly recommend that you pause the video for a moment, give these problems a try, and then come back to click play when you're ready to go through it together. All right, so number 1, Hannah is renting a moving truck. There's a rental fee of $20 plus 25 cents per mile. If she pays a total of $30, choose the equation below that represents the number of miles she drove, X. So let's take a look at the 4 choices there. We see that all of them are set equal to 30, right? And that makes sense because that's her total bill. So on one side of the equal sign, you have her total bill. On the other side is going to be the stuff that goes into the total. So what goes into the total? Well, it's $20 plus 25 cents per mile. So that 25 cents is dependent on the number of miles she drives, right? The more miles she goes, that 25 cents is going to get multiplied, right? So this is actually really similar to the last example we just looked at. The $30 is going to be equal to 25 cents times the number of miles she drives. And then you're also going to add on the $20 rental fee. So choice B is correct here. Choice A doesn't work because it's missing the number of miles she drove, right? It just says 25 cents plus 20. That does not equal 30. That's not a true equation. Choice C has us multiplying the 25 cents times X and also multiplying it times the $20 rental fee, which we don't really have any reason to do that. And then choice D has us subtracting, right? It says do 25 cents times the number of miles and then subtract $20. There's nothing in the paragraph here that tells us we should be taking $25 off of the price. All right, number 2, Jerome earns $19 an hour as a medical resident. This week he earned $1,330. Choose the equation below that represents the number of hours he worked, X. Okay, so I look at my 4 choices and I see that for all of them, they're all set equal to $1,330, right? So they're all set equal to his total amount that he earned. So we want to think about what belongs on the other side of the equal sign. How are we calculating those total earnings? What goes into his total earnings? Well, if it's $19 an hour, it should be 19 an hour times the number of hours he worked. That's what would give you the total earnings of $1,330. So again, choice B is the one here that says $19 an hour times the number of hours equals $13.30. All right, now we've gotten some practice with writing out equations, right? So basically taking a description of a situation and translating it into an equation, translating it into algebra. Now we're going to talk about actually solving the equation. So actually looking for those missing numbers. So when we say solve an equation, we're looking for a solution. The solution is the value for a variable that makes the equation true, meaning both sides really are equal to each other, right? If you're going to have an equal sign in between two things, they better be equal to each other. So last week, we practiced evaluating functions. So for example, we might have had something like this right here where y equals negative 2x plus 10. And so we were asked to evaluate that for x equals 3. So what we did was we took our function and we inputted the given input value, right? So we plugged 3 in place of x. And then we did that calculation. So it would be negative 2 times 3, which is negative 6. And then plus 10. Negative 6 plus 10 is 4. So that's an example of evaluating an equation or evaluating a function. But in this case, what we're going to be doing is kind of the opposite, where we know what's on the other side of the equal sign, right? We basically know what the y is, but we're going to need to kind of dig our way down to figure out what the x is. So your goal when you're solving an equation is to figure out the value of the variable. That's what it means to solve an equation. So to solve a one variable linear equation, which is what we're going to be focusing on, we use inverse operations. So we want to remember that an operation is those are the things we do with numbers, right? So adding, subtracting, multiplying, dividing, exponents, roots, all that stuff. We are not going to worry about exponents and roots for now. We're going to focus on our 4 basic operations. So when we are working on solving one variable linear equations, we use inverse operations. We always want to be thinking about inverse operations. And what that means is we're remembering that addition and subtraction, they are opposites of each other. They are inverses. That means that the one kind of undoes the work of the other. Let's say I start with 4 and I add 3 to it, right? 4 and then you add 3, you get 7. But then let's say I go ahead and I take away that 3. I end up back where I started. So here the adding and the subtracting, right? They're inverses of each other. They are kind of canceling each other out. They're undoing each other. Same thing with multiplication and division. If I take 4 and I multiply it by 3, I'll get 12. But then if I divide by 3, I end up back where I started. So here, the multiplication and the division are undoing each other. They're canceling each other out. So when you solve an equation, especially when you're solving a linear equation, which is what we're going to focus on, your goal is to get the variable on one side of the equation by itself. So your goal is to end up with a statement at the end of your process that looks like this. It should look like x equals some number, right? Or n equals some number. Because you want to know what the number is. You want to know what the missing number is. So it's your goal to do that by whatever means necessary. So there are lots of tools that you have at your disposal to help you kind of cancel everything out that's next to the variable, right? Get rid of all the stuff that's next to the variable so that it is all by itself on one side of the equal sign. So we're going to start with one-step equations. These are the most basic equations, and they're the most basic equations because they just involve canceling out a single operation. And I'm going to show you what that looks like for kind of all of the basic variations on a one-step equation. So let's start with the first one here. It says 2 plus x equals 10. Now with these very basic equations, you might see right away what the missing value is, right? You might know that, well, 2 plus 8 is 10, right? It can't be anything else. It must be 8. But what we really want to focus on here is we want to focus on the process of getting the variable by itself. We want to focus on the process of solving the equation so that when we get to more complicated equations that we can't just guess what the number is and be right, when we get to more complicated equations, we are comfortable with following this process. So you can use your intuition here or your common sense here. You can use that to help you double check your answers, but I don't want you to just look at this and go, oh, the answer's 8. That's not the point. The point here is to start practicing the steps of solving an equation. So 2 plus x equals 10. Well, let's say we're not sure what x is. How could we figure out what x is? How could we get x by itself so that we have a statement that looks like x equals a number? Well, I would need to get rid of this plus 2, right? I don't want to know what 2 plus x is. I want to know what x is. So what I'm going to do is I'm going to get rid of the 2. I'm going to cancel out the 2 by using inverse operations. So if I have plus 2 here, if 2 is being added to x, how would I cancel out that addition? Well, I would cancel it out with the opposite. I would cancel it out by subtracting, right? So 2 minus 2 is 0. It's nothing. So that will disappear. Now that's all well and good. Right now I've got an x by itself. However, I can't just go around making changes to one side of the equation and ignoring the other side. Because of that equal sign, right, because that's saying that the one side is exactly the same as the other, if I make a change to one side, so if I subtract 2 from one side, I need to do exactly the same thing to the other side. So I just subtracted 2 from the left side of the equation. That means automatically, without even thinking about it, I'm going to come over to the right side of the equation and subtract 2. So now, what do I have left over? Well, on the left side of the equation, all I have remaining is x. And on the right side of the equation, I have 10 minus 2, which is 8. And there we go. That's our solution. Now let's look at the second example here. It says x minus 5 equals negative 1. So again, you might be able to figure out what x is, but we're going to go through the process of getting x by itself on one side of the equal sign. So here, 5 is being subtracted from x. What is the opposite or the inverse of subtraction? Addition. So I'm going to add 5. Minus 5 plus 5 is 0. It becomes nothing. Since I added 5 over on the left side, I'm going to come over to the right side and add 5. So now, on the left side of my equation, all that's remaining is x. On the right side of the equation, negative 1 plus 5, that is equal to 4. Now, I could go ahead and I could double check my solution by replacing it into the original equation. So to check my answer, I'm going to take my solution of 4 and replace it where the x is. And I would double check that this is actually true. So is it true that 4 minus 5 equals negative 1? Yes, it is true. All right, on to the third example here. So we have 4x equals 36. So that's 4 times x equals 36. 4 times some number equals 36. Now again, you might be able to guess what that number has to be, but we're going to go through the process of solving, right? So we're going to get that x by itself. So if x is being multiplied by 4, how do you cancel out multiplication? What is the opposite of multiplication? It's division. So if I want to cancel out that times 4, I'm going to divide by 4. These 4's will cancel out. If you think about it, right, 4 divided by 4 is 1. 1 times x, right, 1 times any number is just itself. So basically, the 4's will just go away. They really become 1, but 1 times x is just x. So essentially, we're left with x. Since I divided by 4 on one side, I'm going to come over to the other side and do exactly the same thing. 36 divided by 4 is 9. And you could check your answer. 4 times 9, does that equal 36? Yes, it does. So our solution is correct. All right, and then on to the last example here. We have 30 is equal to some number divided by 3. 30 is equal to some number divided by 3. Well, when I look on the side that has the variable, so the right side has the variable in this case, it doesn't matter which side because they're equal. That variable is being divided by 3. So to get the variable by itself, I'm going to need to cancel out that division. What is the opposite of division? It's multiplication. So I'm going to take the right side of the equation and I'm going to multiply it by 3. The multiplication and division will cancel each other out just like they did in the previous example with the 4's, right? And since I multiplied the right side of the equation by 3, I'm going to need to multiply the left side of the equation by 3. So the right side of the equation just has x remaining. And then the left side has 3 times 30, which is 90. And you could double check your solution. Is 30 equal to 90 divided by 3? Yes, it is. That's correct. Okay, so let's do one more example. This is an example with subtraction again, but it's a slightly different situation where instead of doing a variable minus a number, now we have a number minus the variable. There are a couple of different ways that you can solve an equation like this. I'll show you one way first. So I'll show you one way that involves just adding and subtracting. So when you look at a situation like this where you're subtracting the variable, you could think of this as you have like a minus sign in front of your variable, or you have like a negative variable. And you could think to yourself, well, that makes things a little more complicated having like a negative variable. And so you could get rid of that negative. How would you get rid of it? Well, if you have minus y, how would you get rid of that? You would get rid of it by adding y, right? Minus y plus y, doesn't matter what y is, those things will cancel each other out. And since you added y on the left side of the equation, you must come over to the other side and add y. So now, over on the left-hand side, all that's remaining is 5. And over on the right side of the equation, we have -1 plus y. Right? We couldn't actually go ahead and add those things together because we don't know what y is, right? You can't add two numbers if you don't know what the numbers are. So -1 plus y. Now, this equation looks pretty similar to what we saw before, right? Where it's just some number plus a variable. Okay, so now let's refocus on our goal of getting that variable by itself, right? We ultimately want y to be on its own on one side of the equal sign. So what are we going to do? Well, we are going to get rid of this -1. We don't want it to be there. Now you might look at the fact that there's addition right here and you might think, oh, well, we need to subtract because subtraction is the opposite of addition. However, if you subtract 1, -1 minus 1 is -2, it's not 0. What we want to do is we want to cancel out that -1. So how would you make -1 go to 0? How would you make it disappear? You would add 1, right? -1 plus 1, that'll become 0. Since I added 1 on the right side, I'm going to come over to the left side and add 1. And so I'm left with 6. Y equals 6. And we can double check our answer by replacing y with our solution. So 5 minus 6, not 5 minus y, 5 minus 6. Does that equal -1? Yes, it does. So we were correct. So when you have this situation where you are subtracting a variable, one way you can deal with it is basically by moving the variable to the other side of the equal sign so that it becomes a nice positive variable for you to deal with. All right, so now let's talk about two-step equations. Two-step equations are where you have two operations that you need to cancel out. And in general, what you will do is, since we are talking about like canceling things out, like undoing operations, instead of following the order of operations, we're basically going to be going backwards through the order of operations. Since we are not like doing calculations, we are undoing calculations. So when you have multiple operations that you need to get rid of, you want to take care of addition and subtraction first, and then deal with multiplication and division. That's kind of a general rule for you. So let's look at the first example. 2x plus 10 equals 40. So I see multiplication and I see addition. So I want to take care of that plus 10 first. I want to cancel out that plus 10 first. So I'm going to subtract 10 from both sides. Those will cancel. And I'll be left with 2x equals 30. Okay, so now all I have left here is multiplication that I need to get rid of. How do you cancel out multiplication? With division. So I'm going to divide by 2. Divide by 2. And so I'm left with x equals 15. We can go ahead and double check that answer by plugging it back into the original equation. 2 times 15 plus 10. Does that equal 40? Well, 2 times 15 is 30, plus 10 is equal to 40. That's correct. All right, number 2, the second example here. X divided by 6 minus 2 equals 2. All right, well, I see division and I see subtraction. So I'm going to cancel out the subtraction first with the opposite, right? Minus 2 plus 2, those will cancel. Do the same thing to the other side. So I am left with x over 6 equals 4. Now I have division remaining here. How do I cancel out division? I do it with multiplication. So I'm going to multiply both sides by 6, and I'm left with x equals 24. You can check your answer. So it would be 24 over 6 minus 2. Does that equal 2? Well, 24 divided by 6 is 4. Minus 2 is 2. So it works out. So here, again, I hope you can kind of see that what we're doing now is the opposite of what we were doing last week, right? Last week we were just like plugging in a number and doing the calculation. Here we are kind of canceling everything out so that we can figure out what that missing number is. All right, third example, 7 minus 2x equals 3. Well, I see here that the term that contains the variable is being subtracted. So this is kind of similar to that example we just did where the variable is being subtracted. So I am going to make my life a little easier by making this term positive. That's one way we could do it. So minus 2x, how would you get rid of that? How would you make it positive? Well, we would add. And then we would do the same thing over here. So now we have 7 equals 3 plus 2x. Okay, so now that variable term is nice and positive. We can get rid of the 3. And then we can get rid of that 2. So 2 times x, cancel it out with division. And we're left with x equals 2. There's another way you could do that. So let me erase what I did here. You could do this without moving that variable term around. So what you would do is you would take care of the addition and subtraction first. So basically you're taking care of the stuff that's like furthest away from the variable. So it would be that 7, right? The 7 isn't touching the variable. It's a little bit further away than the 2. So if we have 7, how are we going to cancel out 7? How are we going to make it go to 0? We would subtract 7. 7 minus 7 is 0. Subtract 7. And so we've got negative 4 over here, and we've got negative 2x over here. So this is saying negative 2 times x. So to cancel it out, we would divide by negative 2 on both sides. And we're left with x equals, and then negative 4 times negative 4 divided by negative 2 would be 2. Right, the negative signs will cancel out. And again, you could check that answer. 7 minus 2 times 2, does that equal 3? 7 minus 4 is 3, so that checks out. Okay, so you may encounter equations that are more complex than a one-step equation or a two-step equation. In that case, there's a couple of other things that you might need to take care of. And so those other things are combining like terms and distribution. I'm going to give you an example of each of those. So if you are looking at an equation, let's say we have 2n plus 4n equals, so 2n plus 4n equals 12, let's say. Well, if you have 2 n's and then you're adding another 4 n's, you can actually go ahead and kind of tidy those up, right? You can combine those terms. And a term, when I say term, a term is basically a term is a number times a variable, or just a number by itself. So in equations, terms are in general the stuff that is separated by addition and subtraction. So like in this equation, 2n is a term, and 4n is a term, and 12 is a term. So like terms are terms that have the same variable, and those variables have the same exponent. So in this example, our terms have the same variable and they have a matching exponent because there's no exponent that we see. So we can go ahead and combine them. Just like I said, if you have 2 n's and then another 4 n's all together, you have 6 n's. And now it's going to be a little bit easier to solve, right? We could divide by 6, and we will get n equals 2. So that's combining like terms, where you are adding or subtracting terms that have the same variable and the same exponent. Another thing that we can sometimes do to solve our equations and make things a little easier for ourselves is to use distribution, or the distributive property. So the distributive property says that, let's say we have 2 times 3 plus 4. Well, you might look at this, and if you're following the order of operations, you would do parentheses first. So 3 plus 4 is 7, and then 2 times 7 is 14. But distribution says that another way we could arrive at the correct answer is we could distribute the multiplication to each of the terms in the parentheses. So we could say, right, this is saying 2 times all of the stuff in the parentheses. So we can say 2 times 3, which is 6, plus 2 times 4, which is 8. And what is 6 plus 8? It's 14. So in the case of distribution, let's say we have 2 times, 2 times 2n plus 3 equals 12. No, equals 14. So 2n plus 3, those aren't like terms, so we can't add them together, right? 2n and 3 doesn't have an n on it, so we can't add them together. We cannot combine them. But we could use distribution. So we can say 2 times 2n, that would become 4n. And 2 times 3 would become 6. So now I just used distribution to get rid of those parentheses and tidy up the left side of my equation a little bit before I start using inverse operations to solve. So now I can continue solving this equation. I'm going to subtract 6. And I'm going to divide by 4. And I'm left way at the bottom here with n equals 2. All right, so a general process for solving linear equations. Oops. A general process for solving linear equations. No matter how complicated your linear equation is, this is a set of steps that you can follow that will give you good guidance to getting to the solution. So first thing you do is you simplify each side of the equation individually. So you kind of cover up one side and just focus on the other and then switch sides. So you would be getting rid of parentheses by using distribution, canceling out denominators, and you'd be combining like terms. So let's see what that looks like for this very complicated looking equation over here, right? You might look at this and think, oh my God, what am I supposed to do? Well, you are just gonna do these 3 things. First, you're gonna see if you need to get rid of parentheses by using distribution, canceling out any denominators, and combining like terms. We're gonna focus on the left side of the equation first. First thing I'm gonna do is I'm going to get rid of these parentheses by using distribution. So I'm going to distribute this minus 2. So minus 2 times x, I'm just going to bring the 4x down. Minus 2 times x is minus 2x. Minus 2 times minus 4 is plus 8. Okay, and then we haven't touched the other side of the equation yet. Continuing to look at the left side, I could go ahead and I could combine like terms. So 4x minus 2x. 4 x's, take away 2 x's, you have 2 x's left over. So that's going to be 2x plus 8 equals 7x plus 1. So now the left side of the equation is kind of tidied up as much as we can. Sorry, 7x plus 1 over 2. The left side of the equation is tidied up as much as we can. We've combined everything we can. Now we want to go to the other side of the equation, the right side of the equation. Over here, I see a denominator. I see that everything on the right side is being divided by 2. I want to cancel out that division by 2. It's just going to make my life a little easier. So the way that I do that is by multiplying by 2. Right, that's the same thing we saw before, right? The way that you cancel out division is with multiplication. So the multiplication and division will cancel. That means we also need to multiply the other side of the equation by 2. That means we're going to distribute again. So we're going to end up with 4x plus 16 equals 7x plus 1. Okay, so that was quite a bit of work we just did, but we have simplified our equation a lot, right? There's nothing in the denominator there. There's no more parentheses. We've combined all the like terms we can. So we have completed the first phase of our process. Now on to the second phase is to get the variable term on one side of the equation. So I look at my equation now, and I see that there's two variable terms, one on each side of the equal sign. We don't want that, right? Because ultimately it is our goal to have the variable by itself on one side of the equation. So we don't want it on both sides, just one side. So what we're gonna do is we're gonna pick one of these variable terms to cancel out. Doesn't matter which one you choose. So I'm going to cancel out the 7x. How do I get rid of it? Well, I just take it away. 7x minus 7x is 0. It goes away. Since I subtracted 7x on one side, I need to subtract 7x on the other side, which means I'm going to combine like terms. So remaining on the right side, I will just have that plus 1. And over on the left-hand side, I've still got that 16. 4x minus 7x will give me negative 3x. Okay, so we're looking better now, right? Got the variable on one side of the equation. We have completed phase 2. Now on to phase 3. This should look like just a normal two-step equation now, right? We've got negative 3 times x, and then plus 16. So now we're gonna isolate the variable using inverse operations. This is what we've already practiced so far with solving equations. So I'm going to cancel out the addition first. So I'll have negative 3x equals 1 minus 16, which is negative 15. And then I'm gonna cancel out that multiplication with division. And so we're left with x equals 5. And that's the answer. So going through this process confidently definitely takes some practice. So you, like I said, you want to start with the basics. You want to start with those one-step equations and practice them until you're super confident. Then you move on to two-step equations and you practice those until you're super confident. And from there, you can build up to more complex equations. But it really is a matter of just applying kind of these same principles of like using inverse operations to cancel things out. That's the main thing that you're doing here. Okay, let's do some practice before we wrap things up. So number 1, Tori is planning to sell some t-shirts in her store. The following equation shows how much she'll have to pay for the shirts based on the number of shirts she orders from the supplier. So we have C equals $5.99 plus $1.50 T. If Tori can pay $80.99 for the shirts, how many shirts can she order? Okay, so this equation that they give us tells us how much she'll have to pay. I'm guessing that's C for cost. So the cost is $5.99. It's maybe shipping. $5.99 in shipping plus $1.50 times the number of shirts she orders, right? This is the cost based on the number of shirts she orders. So the cost is going to be $5.99 plus $1.50 times the number of shirts. So I'm guessing it's $1.50 per shirt. So Tori can pay $80.99, right? That's the total cost that she can handle. So I'm going to replace cost with $80.99. And that's going to be equal to $5.99 plus $1.50 T. So how many shirts can she order? Now we just need to solve this equation. So I'm going to deal with the $5.99, subtracting it from both sides. And so now we know that it's going to be $75 equals $1.50 times the number of shirts. So basically, ignoring the shipping cost, she can spend $75 on her shirts. And so we divide by the cost per shirt. And we are left with, we do a quick calculation here, 75 divided by $1.50 is 50. So she can order 50 t-shirts. All right, number 2, 30 is equal to the sum of 6 and twice an unknown number. What is the unknown number? So first thing I'm going to do is I'm going to translate that first sentence into an equation. 30 is equal to the sum, which means addition, right? Sum means adding. So what are the two things we're adding? Well, we're adding 6 and twice an unknown number, so 2 times an unknown number. And there's our equation. And now we can solve it. So I'm going to cancel out the 6. And then I'm going to cancel out the 2 using division. And so we're left with the number is equal to 12. All right, everybody. Well, thank you so much for joining me in this lesson today. Like I said, solving equations and writing equations, it takes a lot of practice, right? You are getting used to the language that is used in the problems, and you're getting used to all of those steps that are being used to solve the equation. So we want to start simple and then build up slowly. Of course, if you ever want more practice or need extra practice, get in touch with me and I will be more than happy to provide you with extra practice. I know this is something that you can handle and I am here to help. So again, thank you for watching and I hope you're having a great week. Take care.